Okay, so today I'm going to do Chapter 11, number 16. We're supposed to consider the following network representation of a transportation problem. The supplies, demands, and transportation costs per unit are shown on the network. What is the optimal cost minimizing distribution plan? And so what they give us here is supplies are here, 30 for Jefferson City, 20 for Omaha, and we're supposed to distribute them to Des Moines, supposed to get 25, Kansas City 15, St. Louis 10. That's their demands. And so we can do that. We can this is kind of the cost per unit shipping. And so 14 going this way, 16 here, 7, then 8, 10, and 5. And so I've kind of labeled these as X11 because this is be the position 1 and this will be the position 2 for the first number. And then we're going to the first one over here. So 1, 1, 1, 2, 1, 3, and this will be 2, 1, 2, 2, and 2, 3. And so that's why the labeling here. And so then I can easily write down what that means. So the X11 is basically shipped from Jefferson City to Des Moines, and then 1, 2 is from Jefferson City to Kansas City, and then Jefferson City to St. Louis is X13. And then the 2, 1 is the amount shipped from Omaha to Des Moines, then 2, 2 is from Omaha to Kansas City, and 2, 3 is from Omaha to St. Louis. Now, what we're supposed to do is minimize the cost. So what we have to do is we have to take and add all the costs together, and we want to minimize that. So we're going to take the cost times basically the label here. So 14 times X11 plus 16 times X12 plus 7 times X13, and then plus 8 times X21 plus 10 times X22 plus 5 times X23, and that is going to be our item we want to minimize. Now, what do we know though? Okay, so what do we know? Well, for here, the one position for the Jefferson City, we know that 1, 1 plus the 1, 2 plus the 1, 3, that has to be less than or equal to 30 because that's all the supplies they have total. And then for the 2, 1, 2, 2, and 2, 3, it has to be less than or equal to 20 because that's all the supplies they have total. Now, when we get to Des Moines, we can either get there 1, 1 or 2, 1. And if we take the X11 plus the X21, that has to equal 25. And then similarly, X12, X22, that has to be total 15, so that equals 15. And then 1, 3, and 2, 3, that has to total 10. And all of these values basically have to be greater than or equal to 0. All right. So now what we need to do is optimize that. So we need to make a model. And so the model here is, this is going to be our transportation problem. We have our parameters. Now our parameters are basically those costs. And so from Jefferson City to Des Moines was $14, to Kansas City was 16, and St. Louis was 7. And then Omaha to Des Moines was 8, then to Kansas City was 10, and St. Louis was 5. And our supply was 30 and 20. Now what we can do is we can sum those together here, and that's going to be, actually, sorry, not sum. That's going to be the demand for Des Moines. So that's going back to the demands over here, sorry. And then this is going to be the demand for Kansas City was 15 and demand for St. Louis was 10. All right, now what we want to do is we want to model this. So we need to find what is the optimal numbers we're going to actually ship then. And so that's what we need to find: this number, and this number, and this number, and this number, and this number. And then we're going to sum those up. Those sums, that's going to be this. Total shipped is just going to be the sum of those 3. And when we sum those up, that's going to be the total shipped here. And then this then will be basically the total ship to Des Moines, to Kansas City, and to St. Louis. And then our total cost is basically the number in B6 times the number in B15 plus the number in B7 times the number in B6. I guess it's B15, then this is B16, and then C6 times C15 and C7 times C16, and so on. And so that's called the sum product. And so we're taking this basically array times this array and adding them all together. Now, I've already kind of typed it in one time just to kind of see, to make sure it worked before I do this. And this time I actually deleted it. So what we have to do is we have to actually type it all in. So we're going to go to Solver. And so our objective is this. I don't know why that stayed there, but it stayed there. Now we want to minimize, because that's what we're supposed to do, minimize the cost. And we're going to change the cells. Oops. Change the cells in this area here. That's what we're changing the variables. So we're changing those, and we're going to try to minimize that cost. All right, now what are our constraints? Well, our constraints, let's just add the constraints. There we go. That way we get rid of all the extra stuff. And what we're going to do is we want to look at the B, let's see where we're at now, 17 to D17. We want to look at those, the total shipped. That has to be equal basically to the demand. We can't get more than the demand, or we don't want to ship more than the demand. And so what we're going to do is the B17, that's going to be our reference, has to be equal to, and our constraint is this. So that's going to be our constraint. So that's going to be our first one. So we can add that. And then what else do we have? Well, our total shipped, the E15 and E16, that has to be less than or equal to what the supply is, because it can't be more than the supply. And so what we have to say is that's going to be less than or equal to that, because we can't have it to be greater than the supply. So that's why the less than or equal to. And we're not necessarily going to be equal to, so it has to be that less than or equal to. And so let's add that one. And then we should be done with all our constraints. Cell box, okay. Let's just cancel and it should be there. Yeah. All right, so now we have our objective. We want to minimize the, what we want to minimize is here. These are our two constraints. And now we want the simplex LP method. And now we should be able to say solve, and hopefully it will give us this thing. Solver found the solution, all constraints and optimality conditions are satisfied. So let's keep that solution and say okay. And so what it tells us, we're going to ship 20 from Jefferson City to Des Moines and 10 to St. Louis for a total of 30. And we're going to ship 5 from Omaha to Des Moines and 15 to Kansas City for a total of 20. And we can see our totals here, 25, 15, 10. And so that's where our demand is. Our total shipped meets our supply, and our minimizing the cost is 540. And so that's how this model would be set up. As far as first we had to kind of set all these items up, and then we had to do this with our solver function. So hopefully that'll help you with 1016, and then I believe 1017, or I'm not 10, 1116, and then 1117 is actually going to refer to this problem. So hopefully doing this problem for you will help you do 1117.